Hi, welcome to my video on the limit at x equals a. That's at the value of x, which will be at a point. The limit at x equals a. If the limit of the f of x as x approaches a from the left side equals the limit of the f of x as x approaches a from the right side, then if the left side equals the right side on the limit, then the limit of the f of x as it approaches a is this number. So if two of these limits from the left and from the right are the same, then the limit of the f of x at a is that number, L limit. Note, the f of a does not have to equal L. So in other words, at a, the function does not have to be equal to the limit. It could be not equal to the limit, but a limit is as it approaches from the left side and approaches from the right side, we should get approximately becoming the same number. As we approach a value of x from the left side and from the right side, and we're getting the same, approaching the same value, then the limit exists. Okay, here we go. Number one, this is the p of x. The limit of the p of x as you approach 0 from the negative, 0 from the left side. As you approach 0 from the left side, we get 1. As you approach 0 from the right side, approaching 0 from the right side, right here, we're coming down here, we get a 1. So these two are equal. So the limit of the p of x at 0 is 1. Because these two are the same, then the limit at 0 is 1. Okay, let's look at some more examples. Number 2, this is the t of x, this diagram. We're approaching negative 1 from the left side. We're approaching negative 1 here. We're approaching negative 1 from this side. So that means we're coming on this function. We're getting a 2. As we approach negative 1, close, coming in here, x is going in here, we're up here, so that means we're getting a 2. Now we're going to approach the negative 1 from the right side. So we're coming in this way on the right side, so we're coming down this curve, and we're getting a negative 3. It's the y value that you approach. And these two are not equal, so that means it does not exist. It does not exist. The limits are not the same. So the limit is not, at negative 1, there's no limit. They're different. And let's look at the h of x. The h of x as you approach 2 from the left side. So where's 2 at? X is 2 right here. We're approaching it from the left side. So we're approaching it from the left side right here. So that means x is coming along here. That means we're going down the graph. We're approaching 2. Now we're going to approach the h of x at 2 on the positive side. So we're coming in here, 2 this way on the positive side, we're going up here, we're approaching 2. And the h of x at 2 is going to be 2, because the two of these are equal, we'll get a 2. Notice that the h of 2 is 2, but that point is not included. The h of 2 is 2, but the point is hollow. So it's not defined. The h of 2 is not defined because it's a hollow dot. But a limit from the left and right is the same. That's what is approaching. It's approaching on the left and approaching on the right. If those two numbers are the same, then the limit at that point is what the value of the left and right is. Number 4. The limit of, this is the f of x. What's the limit as you approach negative 2 on the left side? We're approaching negative 2 right here. And approaching -2 on the left side, so we're coming in here. So this is, and you can see that this is going up and down here. That means that this, I put it in, but you can see it's on this graph. This is the vertical asymptote. So it's going along by that vertical asymptote. So the limit as you approach the -2 on the left side, this is going down, down, down to -infinity. And now, what about we approach -2 on the right side? So we're coming in -2 on the right side here. We're going up and up and up. That's positive infinity. So these are different. So that means since we're approaching -2 from the left and right, they're different. So it does not exist. They got to be approaching the same number. Number 5, the d of x. So we're approaching 1 from the left side. We're approaching 1 from the left side. So we're coming in here. We're getting a 0. We're approaching 1 from the positive side. Can't do it. Does not exist. Therefore, these are not the same, so the limit at 1 does not exist. And another way to represent this is in a piecewise function. So, piecewise function, we have 2 here. So we take the 2 and plug it in here. So 2 times 2 plus 3 gives us 4 plus 3 is 7. We're going to put a 2 in here. 3 times 2 plus 1 is 7. So if you approach 2 from the positive side, this x is greater than 2. Greater than 2 is the positive side. It's on the right side of 2. Greater than is on the right side of 2. So the limit right here is that as you approach it, you'll come to a 7. And if you do it on the left side, 2 on the left side is this one. Left side is less than 2. And we put 2 in here, we get a 7. And what's the limit of the f of x as you approach 2? The answer is 7. The left side equals the right side 7, so the limit of the f of x at 2 is a 7. Remember, there's no equal there. The point, so notice the point. If you had a 2, 7, so that point is not included. So there's a hole. So the point 2, 7 on the graph will be a hole because there's no equal to 2. If you're equal to 2, you get a 7. If you're equal to 2 here, you get a 7. But it's not equal to 2, so the point 2, 7 is not included. There's a hole in the graph. And we also look at it from the point of view of a table of values to represent. And again, you have to find out where you're going to in relation. Notice the table of values here of the g of x. You got 2.8, 2.9, 2.99. You're getting closer to 3. This is 3.2, 3.1, 3.01 is getting closer and closer to 3. So if you, let's look at it. The limit of the g of x as you approach 3 from the left side. 3 from the left side would be, this is on the left of it, so 3 from the left side as you're approaching it here, you're coming in, getting closer and closer. You are approaching, notice, that's a 4.1. So you're approaching, coming into this 4. So this is 4.1, this is a 4. As you're approaching 3 from the right side, and this is the right side, 3.2 is on the right of 3, so this is the right side. As you're coming in, getting closer to 3, again, you get coming in, you can see you're getting closer and closer to the 4. So the limit at 3 is the 4. Two of them are equal. The g of 4, sorry, I should say the g of, my mistake, the g of 3 is 4. That should be a 3, not the g of 4. The g of 3, that should be a 3, my mistake. The g of 3 is 4. So, again, in terms of a limit, you have to look at it approaching from the left side and approaching it from the right side of that value of x. Here's another table, very, very similar to what I just did, but it's the v of x, another. So now I'm approaching, looks like I'm asking you to approach 1. So 1 is what we're approaching. So, right here, the v of 1, I already got to fill in. The v of 1 is 5. I got to fill in already. Didn't know I filled it in, but that's okay. So we're approaching 1 on the left side. And the left side is smaller as this side. Okay, so that's a 1. That's 0.9, 0.8 in terms of the graph. This is the left side here. So as I approach it on this left side, I'm approaching, notice, I'm approaching 0.999. That's approaching, it's getting 0.7, 0.97, 0.99, 0.999. I'm approaching 1. I'm not approaching the 5. The value of x is 1 is 5. But notice this is getting closer and closer to 1. Let's look at this one. As I get closer and closer to 1 on the right side, this is 1.7, 1.3, 1.03, 1.003. So it's getting closer and closer to 1. And so what's the limit of the v of x as you approach 1? The answer is 1. Even though it's where it's defined, when x is 1, this is a 5. Notice this is approaching 1. So on a graph, if you can think 1 gives you, let's say 1 gives you a 5. The 1 gives you a 5 right there. But this is approaching, as you come in on the left side, it's approaching 1. So you can see it's 1 is here, 0.8. So you're coming in, and I'm just going to draw a rough estimate. You're coming in, and each time you move on the left side, you're coming in and you're approaching the 1, like that. And over here, as you're coming in on this side, this is a 2. So 1.2 is right here. So as you get closer and closer to 1 here, whatever this graph is going to do, it could go down here, it could go up here, it could go straight. I'm just going to go up here. It's just doing that. So it's approaching to 1. It's coming in. It's just getting smaller and smaller and smaller. So it's approaching that 1 right there. Hopefully you understand what I'm saying. Here, it's going to a 4. This is 4.1, 4.1. And so in between here, we're going to take more of these and get closer and closer to the 4. But this is not true here. I'm getting closer and closer to 1 on here, but not getting closer to the 5. So hopefully you understand that a limit at a point at a value of x is the same value as you come in on the left that you come in on the right. Hopefully the video explains that. And again, click the like button, click the subscribe button, visit my math website, www.mathfullyexplained.com, to find more information about me, my video, and the content. The content on my YouTube channel called Math Fully Explained, which is just one word. Thank you for viewing my video. Hope the video helped you. Bye-bye.